NCERT Solutions, Class 10, Mathematics, Chapter 1, Exercise 1.1, Question 1. Express each number as a product of its prime factors. 140, 156, 3825, 5005 and 7429. We are going to write each given number as a product of its prime factors. Prime factors means prime numbers. Therefore, we are going to write each number as a product of prime numbers. What are the prime numbers? 2, 3, 5, 7, 11, 13, 17, 19 and so on. First, look at 140. Check divisibility by 2. 140 is an even number. Therefore, it is divisible by 2, which is a prime number. Divide 140 by 2. 140 divided by 2 is 70. Now we have 70. This is also even. So, again it is divisible by 2. Divide 70 by 2. 70 divided by 2 is 35. Now we have 35. Check its divisibility by 2. Since 35 is not an even number, it is not divisible by 2. Next, check if it is divisible by prime number 3. A number is divisible by 3 if the sum of its digits is divisible by 3. The sum of the digits of 35 is 3 plus 5 is equal to 8, which is not divisible by 3. So, 35 is not divisible by 3. Let us try the next prime number, which is 5. The last digit of 35 is 5. Therefore, it is divisible by 5. Divide 35 by 5. 35 divided by 5 is 7. Now we get 7. The number 7 is already a prime number. Therefore, we can stop the division process. So, the prime factors of 140 are 2, 2, 5 and 7. Let us write them as a product. We get 2 into 2 into 5 into 7. 2 into 2 can be written as 2 square. Therefore, 140 is equal to 2 square into 5 into 7. Now look at the second problem, 156. 156 is an even number. Therefore, it is divisible by 2. Divide 156 by 2. 156 divided by 2 is 7 times and then 8. 78. Now we have 78. 78 is also an even number. So, again it is divisible by 2. Divide 78 by 2. 78 divided by 2 is 3 times and then we have 18, which is 9 times. Now we have 39. 39 is not even. So, not divisible by 2. Check divisibility by 3. The sum of the digits of 39 is 3 plus 9, which is equal to 12. 12 is divisible by 3. So, 39 is also divisible by 3. Divide 39 by 3. 39 divided by 3 is 1, 3, which is 13. Now we get 13. The number 13 is already a prime number. Therefore, we can stop the prime factorization. The prime factors of 156 are 2, 2, 3 and 13. As a product, 156 can be written as 2 times 2 times 3 times 13. 2 into 2 can be written as 2 square. Therefore, we get 156 is equal to 2 square into 3 into 13. Now the third problem, 3825, 3825. Start with the smallest prime, 2. Since 3825 is odd number, it is not divisible by 2. So we will not check 2 again for any of the later numbers. The next prime we can check is 3. The sum of digits in the number 3825 is 3 plus 8 plus 2 plus 5, which is equal to 18. 18 is divisible by 3. So 3825 is also divisible by 3. Divide 3825 by 3. 3825 divided by 3 is 1 time, 2 times, and then we have a remainder of 2. 22 is like 27 times 21, which is equal to 1275. Now we have 1275. We will continue checking with the same prime number 3. The sum of digits of 1275 is 1 plus 2 plus 7 plus 5, which is equal to 15. 15 is divisible by 3. So 1275 is also divisible by 3. Divide 1275 by 3. 4, 2, 5. Now we have 425. Check divisibility by 3. The sum of digits is 4 plus 2 plus 5, which is equal to 11. 11 is not divisible by 3. So we will not check 3 again for any of the later numbers. The next prime number is 5. The last digit of the number 425 is 5. Since a number is divisible by 5 if it ends with 0 or 5, 425 is divisible by 5. Divide 425 by 5. 425 divided by 5 is 8 times, and then we have 5 times, 85. Now we have 85. Continue checking with the prime number 5. The last digit of 85 is 5. So 85 is divisible by 5. Divide 85 by 5. 85 divided by 5 is 1 times, and then we have 7 times, 17. Now check 17. Now check the divisibility of 17 by 5. The last digit is 7, so it is not divisible by 5. So we will move to the next prime number. The next prime number is 7. 17 is not divisible by 7. And similarly, 17 is not divisible by 11 or 13. Then we have 17. 17 is already a prime number. Therefore, we can stop the prime factorization for the given number. The prime factors of 3825 are 3, 3, 5, 5 and 17. As a product, we can write this as 3 times 3 times 5 times 5 times 17. 3 times 3 can be written as 3 square, and 5 times 5 can be written as 5 square. Therefore, 3825 is equal to 3 square into 5 square into 17. Now we have the fourth problem, 5005. Let us check the divisibility by 2. 5005 is an odd number. Therefore, it is not divisible by 2. Let us check the divisibility by next prime number 3. The sum of the digits in the number 5005 is 5 plus 0 plus 0 plus 5 is equal to 10. Is not divisible by 3. Therefore, this is not divisible by 3. Next prime number is 5. Let us check the divisibility of 5005 by 5. Since 5005 ends with 5, it is divisible by 5. Divide 5005 by 5, which is equal to 1001. Now we have 1001. Since it does not end with 5 or 0, it is not divisible by 5. Let us try the next prime number 7. Let us test it. Yeah, 1001 is divisible by 7 and we get 143 as a quotient with no remainder. Now we have 143. Let us check its divisibility by 7. 143 divided by 7 leaves a remainder. Therefore, 143 is not divisible by 7. Let us try the next prime number 11. 11 divides 143 exactly and leaves a quotient of 1, 3. Now we get 13. Thirteen is already a prime number. Therefore, we can stop the prime factorization for 5005. So the prime factors of 5005 are 5, 7, 11 and 13. Therefore, we can write 5005 as 5 times 7 times 11 times 13. Next problem we have 7429. Let us check its divisibility by 2. Since 7429 ends with an odd number, it is not divisible by 2. Let us check its divisibility by 3. The sum of the digits in 7429 is 7 plus 4 plus 2 plus 9, which is equal to 22. Since 22 is not divisible by 3, 7429 is not divisible by 3. Next, check the divisibility by 5. Since last digit is 9, which is not 0 or 5, it is not divisible by 5. Now we move to the next prime number 7. The value 7429 divided by 7 is not a whole number, which means it is leaving a remainder. So 7 is not a factor. Try the next prime 11. 7429 divided by 11 leaves a remainder. Therefore 11 is also not a factor. Now try the next prime number 13. 7429 divided by 13. Dividing by 13 also leaves a remainder. Therefore 13 is not a factor for 7429. Let us move to the next prime number 17. When we divide 7429 by 17, we get 437 with no remainder left. Therefore 17 is a prime factor. Now we have 437. Try dividing 437 by 17. It leaves a non-zero remainder. Therefore 17 is not a prime factor for 437. Let us try the next prime number 19. When we divide 437 by 19, we get 23, leaving no remainder. Therefore 19 is a factor for 437. Now we have 23. 23 is already a prime number. Therefore the prime factors of 7429 are 17, 19 and 23. Therefore 7429 can be written as 17 times 19 times 23.